Same problem. Example 2. We're going to come back to C, so let's look at letter D. How long does it take for the object to reach a height of 2,640? So how long tells us we're looking for what? Time, right?
Well, we already found time earlier.
We found time of the maximum height, right? This is asking us to find the time when the height is 2,640. So what do you think we're going to do with that 2,640? Plug it in for our h of t, because we're not plugging it in for time. The time is not 2,640 seconds, right? That's a long time. The height is 2,640. So we're plugging the 2,640 in for the entire h of t, which represents your height. So we have 2,640 equal to negative 16t squared plus 256t plus 1680.
So we're plugging it into T.
We're plugging 2,640 in for h of t. All right. How are we going to solve this problem?
Would you set it to 0?
Okay, we usually need to set these problems equal to 0, right? So if I want to get this equal to 0, I need to get rid of that 2,640. So how do we move it to the other side? Good. Subtract it. Okay, so subtract 2,640. Subtract from like terms. Ryan, what'd you get? Negative 960? Okay. Now that we have it set equal to 0, it looks awfully similar to part D in example 1. So why don't you look at example 1, D, and see if you can figure out that next step on your own. Look at example D on the previous page. See if you can figure out this next step on your own. Bless you. The hint for the greatest common factor is to see if that leading number can divide into all of them. So if I were you, I'd see if 16 can divide into all of them. And I would divide by a negative 16. Then that's going to make your t squared term positive. So we have a positive 60. What two numbers multiply to get positive 60? And add to get a negative 16.
Negative 10, negative 6.
Okay, Dalton is helping you out. He said negative 10, negative 6. I'd agree with that. Can we just take the shortcut, Vinny?
Yes.
Because why?
Because there's just the t squared.
Good, there's just a 1 in front. Good. So t minus 10, t minus 6. What do we do at this point? Alyssa, what do we do at this point when we have our 2 parentheses set up like this? What do we do here? Well, you're right. What did you say? Split them. Right. We're going to split them down the middle and we're going to separate them out. Right? So we can set each of them equal to 0. So I have t minus 10 equals 0. T minus 6 equals 0. T equals 6 and t equals 10. Which one do we want to keep as our answer? Think about what it's asking. How long does it take for the object to reach 2,640 feet? What do you guys think?
I'm thinking we need to add those variables.
Ooh, no, no, no. Oh, no.
All that I'm.
Would you guys agree if something goes up, it must come down? So if this is the height of 2,640 right here, it's going to hit it on the way up and on the way down, right? So it could hit it at 6 seconds and again at 10 seconds. So it's going to hit it up 2,640 on the way up at 6 seconds and then back on the way down at 10 seconds. So we're going to use both of these answers, okay? So we would say the object reaches 2,640 feet at 6 and 10 seconds. Okay, with that in mind, let's think about letter C. How much does the object travel during the 2 seconds between 5 seconds and 7 seconds? So look at this picture that I drew. If it was 6 and 10, I want to figure out how much the object is traveling between here and here. How could I figure that out? Someone besides Leanna, because she's talking for the whole class today. How can you figure out how much height has passed between these 2 seconds? John?
Maybe take the maximum height minus what it is at 6 or 10.
You're getting closer.
Minus 10 from 6.
Not 10 minus 6. Taylor?
Minus the 5 and the 7 to the 10 and the 6.
Okay, so remember 6 and 10 is a completely separate problem. I just use this as an example. Guys, does that make sense? If I find the height at 6 seconds and I know the height at 10 seconds, if I subtract those two, isn't that going to give me what's left? How much it traveled between those two? So if I find the height at 5 seconds and I find the height at 7 seconds, right? Maybe the height at 5 seconds is 200 and the height at 7 seconds is 300. How much did it pass? It's a Monday, isn't it? Okay. Miss Carolyn?
I think that why the question was kind of confusing is because with the 6 and 10 example, they were at the same height. And so then it looked like if we say, I don't know what I mean, like the subtraction would be like with the same number in that case.
I see. So if we talk about 5 seconds and 7 seconds here and here, when they're not at the same height, if I were to subtract these two numbers, right, take this number away from this number, that would give me how much it moved. Would you guys agree with that? Okay, so we need to find the height at 5 seconds, and we need to find the height at 7 seconds. So what are we going to do to find the height at 5 seconds, Lexi? How do you find the height at 5 seconds? What is 5 giving us? What variable in our equation is 5? Is it the height or is it the time?
It's the
It's the time, right? So we're going to find out what h of 5 is, which means we're plugging 5 in for our t. And then we're also figuring out what h of 7 is when our t is 7. Okay, so you have two problems to work out. Go ahead and work them out on your paper. We're using the same formula or the same equation in example 2. So the one at the very top there, we're going to use that to evaluate h of 5, and we're going to do that to evaluate h of 7. The 5-second one? Did you do the 7 one first? What'd you get after 7 seconds? What have you been doing for 10 minutes? Cade, what'd you get after 5 seconds? 2,880. Does anyone else agree with that? The height after 5, hang on. Height after 5 seconds? Let's see. No, you're fine. You probably just chill out. Did you do, Crystal, what'd you get height of 5 seconds?
2,560.
2,560 after 5 seconds?
Yep.
Anybody else? Okay. The height after 7 seconds? Taylor?
2,688.
Okay. And what are we supposed to do now? Subtract the 2. So 2,688 minus 2,560. Samantha says 128. Does anyone agree with that? Okay, so what's our sentence going to be here? Lena, you're closed down for the day. Braxton, thank you for offering your answer.
Ball traveled 128 feet between 5 and 7 seconds.
Perfect. So Braxton said the ball traveled 128 feet. What did you say during 5 and 7 seconds? Between. That's a good word instead. Between 5 and 7 seconds. Some of you are forgetting to square your time, which is why you're not getting the right answer. Some of you are forgetting to square right here. The formula says that you have to square this number, so make sure you do that. Any questions on letter C? We're almost done, but we're doing these so that you can do well in your homework today. All right? So let's go to letter E. In fact, I want you to try letter E on your own based on letter D that we've already done.
Actually,
So letter E says, how long does it take for the object to hit the ground? We've already done one like that. 1D is exactly like 2E. Okay, so I'd like for you to take a few minutes, and I'd like for you to solve part E based on the example 1D. Okay? If you're watching the video, go ahead and press pause. When we say that we should use the positive one, why do we know that we don't have to use the negative one? Olivia, say that again. Zero is on the ground. Negative represents time.
You can go back.
There you go. You can't go back in time, right? We are not back to the future. So we cannot go back in time. So this will never work. The negative will not work. So 21 is going to be our answer. Who wants to give me my sentence? Vinny.
The ball takes 21 seconds for the object. Yeah. The ball takes 21 seconds to hit the ground.
Good. The ball takes 21 seconds to hit the ground. Or after 21 seconds, the ball is on the ground, or the ball is on the ground after 21 seconds. There's multiple ways to write it. Okay, questions on letter E? Before we get to the last one? We're almost there. Now, your story problems in your homework will not take you this long. You're just learning this today, so we're talking through why we're doing them, and we're going slower to make sure everybody's on the same page. When you get to your homework page, it's worded the same, so that's why you have notes that shows you how to do each kind of example, okay?
Now, will we have like A, B, C, and D?
On some of them are cram-packed together, like what is the maximum height, how long is it, how long does it take to get to it, in the same question. Yeah, so you can break it apart to A, B, and C. Okay, example 3 says the area of a rectangle is 1,260 square meters. Find the dimensions of the rectangle if we know that one side is 48 meters longer than 3 times the other side. Seems like a lot. Let's first draw a rectangle, because it helps to visualize things. And in geometry, we will draw a lot, so let's get used to it. We're going to draw a rectangle. It says the area inside is 1,260 square meters. Does anybody remember the area of a rectangle formula?
Width plus height.
Close. Width times height. Or length times width, right? There's not really a height in area. So we're going to say the area equals length times width. What piece do we already know in this formula? We know the area, right? So we know the A already is 1,260. So we can plug that in for our area. It says find the dimensions of the rectangle if we know that one side is 48 meters longer than 3 times the other side. There's one side we don't know anything about, right? This is giving us the description. This 48 meters longer than this right here is talking about just one of the sides. We don't know anything about the other side. So the one we don't know anything about, we're just going to call it X. So we don't know anything about one of the sides, we're just going to call it X. Then it says this one is 48 meters longer. How could you write that? What are you doing if it's 48 meters longer? Are you subtracting 48? Are you going to add 48? Are you multiplying by 48? What are you doing? You're adding 48, right? Because if I'm 5 feet taller than you, you're going to add 5 feet onto your height. Okay, so 48, we're going to add 48 to something. And then it says 3 times the other side. Well, what's the other side? Just X. So what's 3 times the other side? 3X, right? So this side is just going to be 3X. So we have one side is X, the other side is 3X plus 48. So now I have my length. I'll let my length be 3X plus 48 times my width, which is X. So this is kind of a newer problem. How do you think we might go about doing this?
Oh, we gotta figure out what X is.
We have to figure out what X is, but first, what do you do when you see parentheses like that and something on the outside? Distribute, right? Okay, so let's go ahead and distribute our X through. 3X times X is 3X plus 48x equals 1,260. Now what do we need to do when we have an x squared problem? Mitchell? Okay, you're on the right track. Before GCF, what do we have to always make sure the problem is set?
I already did that.
Okay, so set it equal to 0, right? So we're going to set it equal to 0, which means I'm subtracting 1260. I'm just going to put it on the end here. And now, Mitchell, what did you say we needed to do?
Find your greatest common factor.
Okay. What might be the hint for our GCF here? The 3, right? Okay, so let's divide 3 out, and I think you guys can finish this. If you're watching the video, go ahead and press pause and finish the problem. So we're talking about measurement of the side of a rectangle. And one of the sides is
What did you get? 16. I thought it was
14. 14. I saw 16 in there. So we know that one of our sides is just x over here. Can we have a side measurement that's negative 30 feet? No. So actually our negative 30 is not going to work, right? So in this answer, the only answer we can use is the 14, but it says find the dimensions of the rectangle. So I know that this side over here is 14. How am I going to figure out how long this top is? What do we need to do here? Plug in the 14 for our x, right? So 3 times 14 plus 48. So we know that this side is 14 because we said x is 14. Now we're going to plug in the x value. 3 times 14 plus 48. Crystal says 90. Does anyone else agree that that's 90? Okay, someone double check that 90 times 14 is 1260. 90 times 14, is that 1260? Woo! Math comes out right. So we would say the dimensions of the rectangle are 14 meters by 90 meters. 14 meters by 90 meters. All right, your homework is to do the first 4 problems on the new worksheet that I'm getting ready to hand to you.